Tällä videolla esitämme käytännön esimerkkejä.
When speaking about this topic, we usually use the term electrostatic discharge protection or ESD protection. Concerning ESD protection, I will demonstrate how to protect against static electricity, garages and the installation of phone appliances. In this presentation, there are tables and diagrams. These can be viewed at leisure after the presentation. I hope you enjoy our short presentation and that you can become acquainted with the practical problems of ESD protection. All personnel employed by our company are required to have a basic understanding of the problems concerning ESD protection. All personnel who come into contact with appliances containing electronic parts or components must have a thorough knowledge and undergo basic training in ESD protection. This includes salesmen, storage personnel, maintenance personnel, etc. Because all vehicles contain components that are sensitive to static electricity, companies need to understand that a working ESD protection system is an extremely important element in maintaining quality of work and operation. A basic prerequisite is that the leadership of the company must lead by example and be wholly committed to ESD protection. ESD protection and training are defined in international standards, and because standardization is a worldwide operation, these standards are valid in all industrial countries. Diagram and the name of ESD standard. Various warning signs and pictures are being used in ESD protection. The need for protection for static electricity is caused by the developments of component technology. During the times of tube technology, static electricity did not always have an adverse effect on electronic appliances, because the components and materials used in the electron tubes were thicker compared to modern electronics. After the invention of the electron tube, the next step in electronic development was the transistor. With the invention of transistors, the size of the appliances were dramatically reduced. A practical example would be a portable radio, which were commonly called transistor radios. Nowadays, it's commonplace to find such small radios. For instance, we have radios in our mobile phones. In the 1960s, the transistor was this size. Now hundreds of millions of transistors with the same function are being packed onto a silicon chip. From this view of the component, you can see the silicon chip in which there are hundreds of millions of transistors. When we look inside a silicon chip, we can see very thin folios. The current and voltage that are created in the discharge of static electricity harms or destroys these micro-thin foils. The width of these microfoils are under 1 micrometer, meaning that the width of a foil is only 5 to 10 thousandths of a millimeter. The defects caused by static electricity to the foils of the components are, for example, intense flows might burn the foils until they break. When this occurs, we are speaking about the so-called steaming of the foils. High voltage might jump between or across the foils, in which case foils can be welded together, resulting in short circuits. High voltage can burn through the insulation between foils, at the same time harming the foils. Most faults caused by static electricity are the so-called hidden faults. These can occur days, weeks or even months after the initial incident that caused the problem, for example, repairing an appliance.
Näitä piileviä vikoja ei voida välttää
We must remember that the only way to avoid these hidden faults is by diligently applying and following systematic and careful ESD protection. There is no shortcut. If you want to elevate your standards of workmanship, ESD protection is a fundamental step. This kind of electron tube or transistor cannot readily be broken by the kind of discharge of static electricity in the same way that the equivalent modern component could be. By densely packing components, we allow lower voltage usage. As we pack components tighter together, this usage voltage will continue to fall. In modern electronic equipment, the day of the 1 volt usage voltages are being approached. This is one of the reasons why modern electronics are prone to different kinds of external interference signals. Building an appliance that is well protected against interference signals is extremely expensive. For this reason alone, consumer electronics cannot be adequately protected. The life expectancy of electronic appliances is being optimized for only a few years. A good example is the mobile phone. Car electronics are often liable to interference travelling through the wires in the car. For instance, the current of an ESD discharge and voltage can travel through the wires to equipment containing electronic components, causing temporary malfunctions. In this case, we are talking about deficiencies in EMI protection, also the connection of an electromagnetic pulse on the appliance. EMI equals electromagnetic interference. Static electricity is formed everywhere in normal life. Even when handling installation materials, static electricity can easily be formed. The pre-index of charged materials changes according to how the materials happen to be placed in so-called triboelectrical series. Plastic combs charge negatively in comparison to hair because hair is higher in the triboelectrical series than plastic. Hair charges positively. A wooden comb is closer to hair, and because of that, its charge cannot be verified. A plastic comb is distant from hair in triboelectrical series, so that when the comb is being brushed through the hair, it charges intensively. The electrical field caused by the charge can be measured by an electric meter/voltmeter. After installation/insulation, charges are caused because electrons cannot move in insulation substances. Test normal shoes on ESD floor. This floor is electric leading Torosta 9500 floor mat. My body charges because I am being insulated from the electricity leading floor with ordinary shoes. Now I walk with electric leading shoes and I am in contact to the ground through my shoes and floor so that my body cannot charge notably. When the floor material and the shoes are made of the right type of materials, the earthing works reliably. Unearthed leading material or insulation can be charged positively or negatively. Earthed leading material will not charge. Removing the charge from installation materials can only be done with an ionizer. The ionizer produces giant amounts of negative and positive ions, which are in balance. Remove the charge from a charged plastic item can only be done like this. The formation of static electricity is greatly affected by the relative humidity of the air. When relative humidity is below 10%, static electricity is easily formed because all materials are dry and conduct electricity poorly. During summer, the situation concerning static electricity is noticeably better because relative humidity rises during the summer. For this reason, when purchasing materials, it is essential that all materials being used in ESD production have been tested in a low humidity environment. Static electricity is discharged by month. The damaged tensions of components are very low compared to the kinds of tensions that are developed in normal everyday life. Demo of voltage during everyday life. There are many kinds of discharges of static electricity. In principle, no two static discharges will be alike. In the workplace and working with vehicles can be caused, for example, machine model, human body model, charge device model. The essential difference between these types of eruptions is the speed of discharge and the way and amount of current and capacity. HBM model. I have charged the sheet to approximately 1400 volts and touch the sheet with my finger. I am trying to verify the human body shape discharge this way. To help, I use an EMI locator, a device that reacts to the EMI phenomenon that is generated in the discharge of static electricity. As we see, the beeper does not react. Once more, I have charged the sheet to approximately 1400 volts. This time I touch the sheet with a spanner. The beeper reacts because the discharge is fast and powerful. Slide components onto the sheet and grasp with tweezers. Beeping. As seen in the MM model, where metal touches metal, the discharge speed is extremely fast and powerful. For example, 15 volts in the body is enough to produce approximately a 10 milliamp voltage in a discharge situation with a spanner. With 1000 volts, the stream is over 1 ampere in size. If this kind of voltage spike is being directed to a component, the part or total destruction of the component is possible. ESD discharge is transmitted to components easily via, for example, open joiners.
Elektronisten laitteiden ESD-suojaus on toteutettava valmistuksen, kuljetuksen, käsittelyn ja huollon aikana.
Tässä esityksessä on tarkoitus kertoa staattisen sähkön aiheuttamista ongelmista nykyautojen elektroniikalle. Siihen aikaan kun isä auton osti, ei staattinen sähkö auton elektroniikkaa vaivannut, koska sitä ei ollut, eikä siitä ajasta niin kauan ole. Puolijohteet ja staattiselle sähkölle herkät komponentit alkoivat tulla yleiseen käyttöön 70-luvun taitteessa, jolloin staattinen sähkö alkoi aiheuttaa ongelmia komponenttien käsittelyssä. Esimerkiksi elektroniikkateollisuudessa staattiselta sähköltä suojaus on pitänyt ottaa huomioon jo vuosikymmenien ajan. Autoissa elektroniikka alkoi yleistyä vasta 90-luvun taitteessa, ja sen tuomaa teknologian muutosta ei vielä oikein ymmärretä, koska asia on varsin uusi. Autoihin elektroniikkaa on tullut viime vuosina huimasti lisää, ja elektroniikan osuus autojen laitteissa kasvaa koko ajan. ESD-suojaus tulee olla itsestäänselvyys elektronisia komponentteja sisältävien laitteiden käsittelyssä. Autojen elektronisten osien vaihtaminen ja varaosien käsittely ei enää onnistu kotioloissa tai yleiskorjaamoissa.
Let us have a look at the difference between the old and new fuel systems. The old ignition system was mainly a mechanical appliance that did not have electricity. In contrast, modern ignition units are electronic. Traditionally, the fuel intake of a car's gasoline motor has been carried out with the aid of mechanical carburetor. In modern cars, gasoline is electronically injected via fuel injectors directly into the cylinder. The servicing bay for a modern car must be completely protected from static electricity. This area is called the EPA area. The floor of this repair bay has to be of a dissipative surface. The resistance of this floor to the ground is 2 megaohms. The combined resistance of the fitter to the ground is approximately 20 megaohms. With this measurement has been made sure that the earthing of the fitter in standing work. This measurement contains the voltage that forms in the fitter's body when walking on half-leaden coating. In the EPA area there is no voltage being generated in the body. When walking outside of the EPA area, voltage begins to be generated immediately. When stepping onto half-leading coating, the body's voltage discharges under control via ESD shoes to the ground, after which the fitter puts on an anti-static wristband. The fitter tests the wristband and shoes before starting the actual work. The fitter ties up the earthing wire to the overall's earthing point before sitting in the car, because when he sits down in the car, the earthing does not work through the shoes. When the earthing wire has been connected, the fitter is earthed when sat down in the car. The car is being earthed on a half-leading floor through tyres, because tyres insulate electricity well. The ability to lead of a car tyre can be proven even with a simple metal cylinder sensor. The reliable earthing of a car has to be done with a separate earthing wire from the car's earthing point. The fitter connects the car to the test machine to locate the fault. After locating the fault, the fitter gets a new part from the storage area. The part has been packed in an anti-static bag. The packet cannot be opened until it is within the EPA area. Once there, the part can be safely changed when the car has been earthed with a separate ground wire and the fitter has been earthed through ESD shoes and half-leading floor. The faulty part is being replaced into the anti-static bag to reduce damage that may be caused while transporting and handling outside the EPA area. The fitter is earthed when removing the air conditioning control unit. When handling any unit, special caution is needed not to touch both unit and joiner contact surfaces simultaneously. Through the contact surface of the joiner, static electricity can be discharged directly into the unit's electronic components. A prerequisite for the safe handling of units with plastic covers is the usage of blow ionizators while handling the unit, because the removal of charge from the plastic cover cannot be done without the help of an ionizator. When handling component discs, ESD protective gloves must always be used because grease and other impurities of ungloved hands remains on the component disc and joiners, causing corrosion and contact interference. Cleaning electronic units and component discs with compressed air is strictly forbidden, with compressed air, oil and water particles dispersed to the units. In addition, impurities, for instance oil, water, sand and dust, penetrate components and the maze of space between the units. With an ionized pressure air pistol, static buildup is eliminated, but the dissemination of impurities in units and component discs is still a problem. The transportation and storage of fuel in charging plastic containers must be avoided. Normal plastic containers generate static when being handled vigorously. During the summer, volatile fuel mixes in tanks become especially flammable. From a plastic fuel container, the charge can short to the metal parts of a car, causing an explosion. In Finland, as well as a plastic fuel can, emulgators container have caused several serious accidents, for example fires at furniture factories. A used empty plastic container is the most inflammatory because an inflammatory fuel-air mixture is easily created. For this reason, fuels and emulgators should be transported and kept in a container made of conductive material. In practice, static buildup in this kind of container is minor. Adding fuel to a car from a conductive container is safer when compared to a charging plastic container. Notice that the filling funnel being used must also be conductive material. Done this way in practice, the potential differences between the container, car and person are minor, and adding fuel is safer compared to using charging plastic containers. Installing additional appliances must be done in the EPA area of a garage. The fitter checks the functioning of the anti-static wristband and the ESD shoes, with shoe and wristband testing device and tie-ups to the additional earthing to ESD clothing before starting work. The additional appliances installed in the vehicle have been brought to the installation place in anti-static protective packing. Anti-static electricity packages can only be opened in the EPA area. The fitter earths himself before entering the vehicle, after which he removes the necessary wrapping and does all other demolitioning work. In a correctly built EPA area, earthing works in different working positions. The fitter does not have to concern himself with earthing matters and can concentrate on the work at hand. Clients and other unauthorized personnel are forbidden from the EPA area. In addition, people working in the EPA designated area must get proper ESD training once a year and must wear the appropriate ESD equipment.
Kuten huomaatte, ESD-suojauksen huomioon ottaminen ei hankaloita työn tekemistä korjaamossa. Tulevaisuudessa ESD-suojauksen huomioon ottaminen tulee entistä tärkeämmäksi autokorjaamossa, koska ajoneuvossa käytettävä elektroniikka kehittyy ja lisääntyy yhä kiihtyvällä vauhdilla. Ilman ESD-suojausta työn laatu heikkenee, kustannukset nousevat ja asiakastyytyväisyys laskee.